Thank you.
Okay, so just a minute. So someone just came around. So I want to move from the room where I am to
Okay.
another room. So give me like, I think we can get this done in 2 minutes.
No problem.
Hi, good afternoon. You want to help me? Please help me to get this to the laptop. Yes. That's it. Okay. Hi, I'm Yes. Okay, thank you. Okay. Osaz, are you there?
Yeah, I'm here.
Okay, great. So sorry about the transmission. So Titi just came into the class, so I had to, because nobody was around, so I was using a smaller room. But now that she's stepped in, I had to split the classroom. So I think the class is also set. By the time you eventually get here, we have a bigger place that can take at least the few people that are going to be coming this afternoon.
Okay.
So Titi, you're welcome. Our Sazwex is on the other side, and this is the innovation that we try to like bring into the class this time around. So for a very long time, this is the first time that we're going to be having a hybrid class. It's been online. It's been online for since I think the last time I had a physical class here was in February. Yeah, that was the last time I had physical class. The only thing I've been doing here has been I've been doing meetings. So so my screen is shared, and please feel free to call me to if you are not hearing my voice. Please feel free to let me know that you are not hearing. So what we did yesterday, just a little bit of recap on some of those things that we discussed yesterday. So yesterday we had the intro into big data where we talked about big data. What are those things that characterize big data? When you say big data, what are those properties that you should see in a data set that will make you conclude that this data set is big data, or whether it's not big data? Those are the things that we simply discussed yesterday. So we talked about the volume of the data, the variety of the data, the velocity of the data. We also talked about the data. Most of the time, they come in unstructured format. Of course, however, there are also some structured kind of data that are also big data. I gave a lot of examples yesterday. I gave MTN example. MTN has 5 million customer base, and an average customer will generate up to about 13 different either inbound or outbound calls in a day. So when you multiply that by 65 million, it's about 650 million records. And then when you multiply by for 30 days in a week and 365 days in a year, you can imagine the kind of data set that a company like MTN is dealing with. MTN is one of those companies that actually implemented an end-to-end big data platform in this country today. It was a huge investment, and it was the Yahoo guys were the guys that they used to do that implementation. Okay, so okay, so that is so that's those are some of the characteristics of big data. Then we also talked about, I'm hearing myself. I think I'm muted. Okay, so we also talk about some of the advantages of big data, some of the uses that you can put big data into. Big data will help you to understand your customer better. Big data can help you to cut costs. I gave the example of how we implemented a big data solution for MTN Nigeria, where not MTN Nigeria this time. Thank you, this is working. But leave the door open. Yeah, so for a bank, so that bank, the challenge they had is what they call ROU cost. Anytime you slot in your ATM card in another bank's ATM machine, there's a cost that is incurred against the bank. It's a huge cost. This particular client paid up to 5 billion naira in a single year in 2019 alone to settle that cost. And they needed to bring down the cost. And at some point, they called us in to help them to they brought us in to help them to cut that cost. It was simply the concept of big data that we applied in order to be able to help them to unravel that particular challenge. So the applications of big data across different industries, it's unbound, it's open-ended. There is no end to what you can apply big data into. In human resource management, although some people do not believe that guys in human resource actually generate anything that is big data. But that is not true. Why that is not true is that the HR guys also generate unstructured kind of data set. In fact, what the guys in Harvard, some kind of study that the guys in Harvard did was they were analyzing the email behavior, email response pattern of a particular organization to be able to determine the level of engagement of people in that organization. And the email data, it's big data. The email data is big data, and to a very large extent, it's unstructured. So whether it's HR, human resource management, or procurement management, or product development, manufacturing, marketing, whatever it is, in pricing, I remember a project we did it with. Oh, I can go on and on, keep giving you examples. The pricing project with a telecom company. That company, they give bonuses to their customers, and they never knew that there have been revenue leakages, up to like 9 billion naira in a single year. And on top of that 9 billion naira bonus, they pay what is called interconnect fee, or they pay what they call interconnect fee, which is another huge cost on them. So with also big data analytics, we were able to help them to identify where they have some of those issues. In merchandising, in sales, and in inventory management, human big data is all applicable in all of this. Yesterday, we also talked about, and I'm having this recap because of Osazua was disconnected from the class yesterday, so he couldn't really follow through this part. So that's why I'm also rushing through it. So there are different types of sources of big data. It could be machine data, so the communication between your phone and a base station, or the communication between your car and a tracking server that is somewhere. It's a machine-to-machine communication. Human being is not really involved. Even when you have your mobile phone and a GPS is communicating somewhere, if you're on Uber and Uber is tracking your mobile phone and is telling you this is the location of the vehicle that is coming, it's a machine communication. When you go to jumia.com and you buy something online, that is a transactional kind of data. When you go to Facebook, you go there to make a post, or you go there to tweet, you go to Twitter to tweet, or go to Instagram to upload a picture. Those are social kind of data. Those are different sources of big data. And then big data itself has evolved over time. It has evolved over time, and there are different requirements that lead to the evolution of big data. So first of all, it's from the need for they needed a platform that can manage real-time data. So I'm generating transaction now. Maybe I'm generating transaction online. I need a platform that will be able to handle it. So from there, they developed the concept of database system. So those database systems come in form of maybe file or hierarchical database or relational database. But that was due to velocity. The rate at which the data was changing was very, very fast. So they needed a system that can capture that kind of a change. When we moved beyond that, then the next need was that there were different kinds of data sets that were now coming. There was now email data, there was email technology that was developed, there was picture technology, pixel technology that was developed, then there was video technology that was developed, and all of these data also need to be captured. So based on that, they also developed systems that can handle all this type of unstructured kind of data. That platform is called, or those type of platform are called NoSQL platform. So you wonder how come when you an email, somebody sent you an email in 2016, that's about 4 years ago, and you can go to Google and just search and it comes out. What makes it possible that it could just come out like that? How did they store the data in their own database system that made that store? Or a document, somebody sent you a document, your CV, you uploaded your CV or your certificate on your email like maybe 10 years ago or 15 years ago, and you will just want to bring it out so that you can print it. You just go online and then you search and it pops up. How is it stored that it's able to come out? So the kind of platform that they use to be able to store that data is called no SQL. It's called no SQL store. That's another kind of invention that came about in the 90s. Then more recently in 2000, 2010, then they developed the concept of Hadoop, and Hadoop is essentially meant to store large volume of data sets, in a way that can guarantee reliability, and that can guarantee um, um, that can reduce what is called single point of failure. So volume became the issue they needed to solve again. And at that point, they now developed what is called big data platform or Hadoop platform, which we are going to be talking about in the coming week. Then, okay, so I think then we talk about different structures of big data. Big data can be structured or unstructured. That can be internally within your organization. Big data can be sourced externally from some other organization. So the data that you might need to analyze in some cases don't necessarily need to all come from your own organization. Sometimes you might need to go to the web to go and scrape the data. Sometimes you might go to some other organization to be able to scrape the data, which is for those that work in the bank, which is one of the challenges that the guys in the bank currently face. There are projects that they give to us in Untitled Analytics, and they will tell us that I want to be sure. Osazwa, are you still there? Let me just check if you are there. Yes, Osazwa is there. Smiler is there. Okay, so one of those things that banks want to, I'll tell you a classical problem that they need external data to solve in the bank. So the guys in Nigerian banks, they want to know before they issue a customer loan, they want to know how that customer is performing in other banks. But they don't have that record. They only have the record of their customer performance in their bank. So how can they issue loan to a customer based on his performance in other banks? And so even if they cannot have access to the customer transaction in other banks, maybe the transaction on switches like Nigeria Interbank settlement system, or their performance on what's it called, on InterSwitch platform or e-transact platform. Maybe that can help them in order to be able to determine the behavior of their customers so that they can issue loans to their customers. Yes, that is um, that is doable, but that will require some kind of partnership between all these different entities, the banks and the switches, to be able to make this data available. But that kind of a problem is a big data problem, and for the banks to be able to have access to this data, they need to communicate with external sources or with third parties in order for them to be able to solve some of those problems. Moving on, data can be. We also discussed yesterday that data types of big data. Data can be structured or unstructured or semi-structured. And I think it was on this note that we ended yesterday. So when the data is structured, it's something that a lot of people are very conversant with. If you have ever worked with Excel, Microsoft Excel sheet, we have data that are stored in rows and columns, or if you worked with what is called relational database, where the data is where the data is stored in an organized environment. So you can simply reference data at a particular point, maybe using indexes or whatever in a normal SQL database. Those are structured databases. For people that use Excel or Microsoft Access or Oracle SQL, those are structured databases. But when you start dealing with the kind of data that is stored on Facebook, for instance, or your email, or that is stored on Instagram, or that is stored on a place like Nairaland or Linda Ikeji. Because on Linda Ikeji, there's also data on Linda Ikeji that can be analyzed. If you need to work with those type of data, they are not structured data. How do you collect them? How do you manage them? But that is another kind of data. It's purely unstructured. Then you now have a third type, which is like a blend of structured and unstructured data. And I'll give you some examples. Your WhatsApp is semi-structured. In the bank, so when you do transaction, there is a transaction narration. That transaction narration is the bank. is unstructured. So, for instance, if I'm paying for DSTV, I'm transferring money to for DSTV, where I need to put the transaction narration, I can just put DSTV. Another person can go there, instead of putting DSTV, the person can say cable TV. Another person can just write satellite TV subscription or DSTV subscription. It's a bit structured because for that kind of data, there is an amount, there is a time the transaction was performed, there is a recipient, and there is a sender, there's a beneficiary, But the fact that the narration itself, which also holds a lot of information, is not structured in any way, while the other details are structured. So when you have a data set where you have a combination of elements that are structured and a combination of elements that are not structured, you can say that it's a semi-structured data set. And I think to a large extent, that was where we ended yesterday. And I think we also talk about some of the challenges of unstructured data sets. Structured data, they are easy to manage, they are easier to handle. In fact, there's almost no problem that you encounter with structured data that today that there is no solution or there is no research on those type of problems. But for unstructured data, it's still to a very large extent a growing field. There are people in the university that are still understanding the growth pattern of unstructured data, how infrastructure should be organized in order to be able to support unstructured data. There is also the governance and data governance and policies that should be put in place around unstructured data. You can see somebody can go to my Facebook page and pick a picture of me and then write something under it as if I was the one who said it. So the person is taking my unstructured data and is also adding his own to it, and then is presenting it as if it's me that said it. Those are some of the issues that are really that the world is facing generally around unstructured data, governance and policy issue. Then integrating unstructured data can come as a problem. Velocity of unstructured data, the variety of unstructured data, it's also some things that could also be some kind of challenge that can be studied. Then you also have regulations and compliance around how unstructured data should be handled, how unstructured data should be manipulated, how it should be assessed. Those are some of the challenges of unstructured data. Okay, so I think that was more or less what happened yesterday. So we've kind of had a recap of what happened yesterday. So today we'll start with the elements of big data, which we also touched on a little bit here yesterday. So each time you talk about big data, there are some characteristics that data must showcase that makes it big data. Without that, big data cannot be said to be big data. Just like you have the characteristics of living thing, Mr. Niger D. What is M again? I forgot what M is. Movement, exactly. It's been long. I did that in GSS1 or primary 6. Okay, so M is movement, R is respiration, and N is nutrition, Niger, I is irritability, then G is growth, E is excretion, and R is respiration or reproduction. Then there is D, which is death, Mr. Niger D. Those are the things that we learned then. The same way for big data. Big data have some characteristics that when you see those characteristics, you must know that, okay, yes, this is big data. And number one is it's the volume. The volume for big data must be something that is approaching exabyte. Exabyte is how many zeros now? So after terabyte, the next thing is exabyte. We did a project with Shell we did a project with Share 2019, and those guys in Share, they gave us just 3 files, one single file. One single file was about 360 gigabytes, one single file. So you imagine they gave us 3 files. 3 files alone were more than 1 terabyte. We didn't even have disk space. Our computers could not load those type of, could not analyze those type of data, because if you dare to copy 3 of those files on your own personal computer, you will not have space to do anything again. There is no application you can put on your own personal computer that can load those type of data. That is what they call big data. Then the example of MTN that I gave, MTN in a day generate about 650 million rows, at least in one single day, 650 million rows in one single day. Then multiply it by 30 days, and now imagine an analyst that is employed in MTN that has to query that kind of data. So it's voluminous. So volume is one of those characteristics of big data. It must be massive amount of data contributed by the organization or individuals within the organization. So that's why I this that's why I this training. That's why I this training. And yeah, so very valid question. Very super valid question. And that is why you're in this training. So it's part of what we are going to be talking about. We are going to be talking about big data framework, like Hadoop framework. So that was what necessitated the development of that Hadoop platform. And let's go a little bit into the history. So it was the Yahoo guys and the Google guys were originally the guys that developed that Hadoop framework, and it's essentially to support all the kind of email and the kind of data that they generate. So you can imagine Yahoo, the kind of data that it amasses, or you can imagine a company like Google, the kind of data that it handles, that it manages. So those are the guys that developed the Hadoop framework, and that's what they use to support the email technology and all of the data that you go to Google to go and search for every now and then. But after a while, they think that okay, the market is also going to need this. They cannot keep it all to themselves, and they try to release it to the market. So that's why companies are now adopting it as the kind of data that they collect and they manage begins to proliferate. So we are going to get into that discussion very, very, very soon. Then velocity. Velocity is the rate of change, the rate of change. So within enterprises, so imagine MTN again, 10 million people are making call at the same time. Imagine the kind of massive data that they are going to be generating. Um, Facebook has 2 billion. Facebook has 2 billion subscribers on it, 2 billion active subscribers. So you imagine 2 billion active subscribers. That is more than the population of a continent, the biggest continent. Okay, maybe not more than Asia, but that is almost like a continent on its own. And people go there, people go there and post, people even go there to find their lovers. So it's like a community for some people. There are people that don't have any business. They do their marketing on Facebook. They sell things on Facebook, they buy things on Facebook, they meet friends on Facebook, people that they've never met before. All of that happen on Facebook. So the question is that um, um, Facebook, it's now a community on its own. It's not a community on its own. So how do you manage the data in that platform? And how do you manage the rate at which data is changing on such a platform? So velocity is one of the characteristics of big data. Then lastly is the variety. So I gave you example of varieties of data set that you can find within an enterprise. If you come to a bank, for instance, the ATM or on the ATM terminal, data is generated on internet banking platform, mobile internet banking platform, data is generated on what's it called? On over the counter, people that walk into the banking branch, they generate data. On internet banking, they generate data. On POS terminal, they generate data. So those are varieties of data sets across multiple channels and multiple platforms. And also at their call center, customers are also calling into their call center, they are generating data. How do you bring all of this data together into a single platform and manage it to make sense that will drive the business forward? So those are varieties of data, and it's a characteristics of um, of big data. So yeah, so based on that, the big data itself, as we have said earlier, has so many applications. You know, I can pick any industry and tell you about the application of big data within that industry. I can pick bank and tell you how you can use big data to detect fraud in a bank, because fraud has a pattern, you know, and when you analyze that pattern over time, you can tell that a transaction is likely going to be a fraudulent transaction. I've given you examples of how big data is performed, is used in a telecom environment. I've given you an example of how big data is used in social media environment. So big data can significantly help in marketing. You know, you see people, if you drive around Lagos in the night, since that end SARS incident that happened, the billboards, the billboards are always alive throughout the night. You see the billboards, they are lit throughout the night. You see companies advertising on billboard. But the billboard technology is no longer in vogue, because a lot of people have now adopted remote work. So people are working remotely. So a lot of people are not even people that have means, you know, are not really like on the road anymore. So why should we invest on billboards when the traffic has shifted from the road to the internet? The traffic is now on the internet. So people are no longer advertising on billboards. People are now advertising on social media pages or on the internet, because that is where you find people that have means to afford some of these products. So you have marketing, social media marketing is so when you now want to decide on which platform should I do my marketing or my brand positioning, for instance, you need to go and analyze maybe traffic on, you have Google, you have Facebook, you have Instagram, you have Twitter, then you have UntiKG, you have Nairaland, you have multiple different channels on the internet where you can go and do your advertising. Now, how do you decide which channel you should choose and which channel you should not choose? Before now, it was radio or TV. But because people are no even longer listening to radio as they used to listen to radio before, people are now on the internet. So we cannot go to radio to say we want to do our advertising. Um, Another application of big data is in segmentation, customer segmentation. And how that customer segmentation works is that a company that has large customer base, how do you segment those customer bases into different buckets, so that when you want to create products, you create products that resonate the to customers within a particular bucket, because there is no one size fits all kind of product for your customer, especially especially in B2C kind of environment, whether you are in insurance business or you are in banking business. You cannot say that if I create this product and I launch it in the market, that everybody is just going to buy into the product just like that. No. Some people may prefer your product, while some people may prefer another alternative of that product. So in trying to determine the segmentation of your customer base, how do you split all of these customers into different groups? Big data can be applied in that case. Then in fraud detection, I'll give you an example for fraud detection. So if you look at the bank, there's a bank. We are supposed to start a project with a bank sometime in October this year, but we couldn't start that project. And what happened was simple. that bank was hit. That bank was hit in October this year. That it even led to suspension of some of the key members of staff of that country. And it is not one bank. I think about 3 banks since the lockdown started. I'm aware of about 3 banks that have been hit. And some of those fraudulent transactions you can predict them. Yes, some of those fraudulent transactions can be predicted. You know, they have a pattern. There's a pattern to those fraudulent transactions. So a fraudulent transaction can be predicted, you know, because they follow a particular, there's a way, they come from a particular kind of IP address, they happen at a particular time of the day, they are peculiar to some particular kind of account, or they are peculiar to some type of transaction. So it is very easy. It is not necessarily very easy, but it is possible to identify whether a transaction is a fraudulent transaction. So, and that will require in trying to solve those type of problems, it might require the application of big data in trying to dictate whether a transaction is a fraudulent transaction or not. I think I can give you some more details on that later on. Then also in trying to determine what are the cost driver for within a particular organization, if you want to know what are the cost driver meaning that we are generating so much cost, but what exactly is that behavior within the customer base that is driving this cost? We want to know so that we'll be able to at least provide some intervention in order to be able to cut the cost. I can give another example because I just have so many of these examples in my head. We did a project with MasterCard, not MasterCard, we did a project with another bank, and what they wanted to do was that at the end of the month, MasterCard sent bill of around 300 and something thousand US dollars to that bank in a month. So a bill of 300 and something thousand US dollars is a lot of money. And if you know how the forex market, how it is in Nigeria, Nigeria keeps depreciating against forex, and the bill that is coming from Master Bank, it has, even if it's not growing, it remains at that level. 300,000 US dollars in January this year is less than 300,000 US dollars in October this year, you know, because of the exchange rate problem. So they wanted to identify what are those customer behavior that is driving the bill that MasterCard is sending to them at the end of the month, you know. So what we also had to do was to go and analyze all the MasterCard transactions that are generated by customer. And the way it is, the MasterCard transaction is generated maybe when the customer inside the MasterCard on maybe ATM machine, or the guy use it to do online betting, or the guy use it to buy something on Jumia, a Nigerian company, or maybe the guy is using it on Amazon, which is an international card, international online, international company relative to Nigeria, or maybe the person is even using his card abroad. Each of those type of transactions generates a different type of bill for MasterCard. So what we did was to analyze all of those transactions and then group similar transactions together. So based on our grouping of these similar transactions, we can now tell that, okay, these are those group of transactions that generate most of the cost lines that you have on the bill that comes from MasterCard. So what some of those banks decide to do is that, okay, maybe instead of giving MasterCard to some classes of customer, because the cost is huge, maybe we should go and look for a VAF card. VAF card is provided by Mintasweet, which is a local alternative for MasterCard. So they could develop new products based on their understanding of customer behavior, and data is what they are using to make some of those decisions. I want to pause a bit so that I can get feedback and questions, then I can proceed. let me check the people who have joined the class. I think Osazua is in traffic. We can see him driving. He's driving to class, and at the same time, he's driving to class, and at the same time, he's following the class. There's Eric connected. Babatunde is connected, and Smiler is connected. While Titi is physically present in the class. Please, if you have any question, please feel free to ask me. If you don't have, then I will proceed. I hope you can hear me so that it will not be like yesterday that I was muted for a very long time. Let me see. Am I? No, I'm not muted this time around. I think you can hear me. Okay, so Eric, can you hear me?
I can hear you.
Thanks a lot, Eric. Okay.
Yeah, thank you very much.
Okay, so let's move to the approaches to analyzing big data. So when you need to analyze big data, what are those common approaches to analyzing big data? There are three main. There are different ways people look at it. Those different approaches to analyzing big data or common analytical approaches to big data. For people that are very conversant, you probably have heard of descriptive analytics, predictive analytics, and prescriptive analytics. And what that means, predictive means, descriptive means looking at data in history, looking at data in historical perspective in order to be able to identify what has happened in the past. So you have descriptive analytics, trying to describe what has happened in the past. How many customers have we onboarded so far? How many customers did we onboard in the month of September? And how many did you onboard in the month of October? You can look at it in relative terms. How have we grown between October and November? That is like descriptive analytics. Then you have predictive analytics, where based on what has happened in the past, can we tell what is likely going to happen in the future? So I was talking about fraud detection. Banks, of course, they have experienced a lot of fraud, and they record fraud from time to time over a period of time. So if we take all of those fraudulent transactions and analyze them, is there a clue that we can get from those transactions that will help us, that is there a clue we can get that will help us to be able to predict that the next transaction that the customer is about to generate is likely going to be a fraudulent transaction? That is predictive analytics. Trying to tell what will happen in the future based on what has happened in the past. Then you also have descriptive analytics, and that approach to big data, or that approach to analyzing big data it tries to recommend, it analyzes data with the intention of recommending the next best course of action that should be taken. I will say that again. So prescriptive tries to analyze data with the intention of recommending the next best course of action that should be taken. So descriptive is looking at what has happened in the past. Predictive is looking at what will likely happen in the future, while prescriptive is recommending the best course of action that should be taken based on what has either happened in the past or based on what will likely happen in the future, or a combination of both of them. And a lot of you have encountered this before. When you go to Jumia to go and buy something on Jumia or Konga, Jumia will tell you that people who view this product also view this type of product, or people who purchase this product also purchase this type of product. What they're actually doing is prescriptive analysis. They are prescribing another product to you based on maybe what you have selected, or based on what other people that are selected, based on what other people have selected in the past. Based on what other people have selected in the past. Those are some approaches to big data. But beyond that, you also have the behavioral analytics, which tries to analyze how businesses can tap into complex data sets. When you look at the behavioral pattern of your customers or behavioral pattern of some entity within a particular organization. So you may want to, a HR analyst, for instance, they want to look at what is the behavioral pattern of the employee to responding to email. So you might want to see, okay, what is the relativity between the time
It's brand new. Medium students.
Normally, this is how a business will use data for predictive and real-time analysis across various. So, really, anything. As anything, I've been doing video. Maybe one video can look blue to quadruple subscribers. Must be competitive. As in, must be, as in, I said competitive. It must be.
audio. Okay, so can you hear me, please? Can you confirm if you can hear me?
I can hear you, but your screen is gone.
Okay, my screen is gone. Thanks. I'm going to bring it back. Okay, so yeah, so here's the screen. Okay, so yeah, so I was talking about behavioral analysis before I got disconnected. So you can analyze different, so yeah, in HR analytics, for instance, you can analyze employee engagement. You can determine employee engagement based on how those employees, the relativity between when the employee received an email and when the employee responded to that email, and the different threads that are generated by the email that an employee responded to. You can use that to determine employee engagement. So it's some kind of behavioral analytics. Then that's something that is called behavioral DNA, where you can take a customer and you can determine, okay, maybe in the past 3 months, what are all the different transactions the customer have generated, how much the customer have generated, what is the frequency of the customer transaction, what is the recency of the customer transaction, what is the number of days that customer generated transaction in a week or in a month, and so on and so forth. So when you have all of that, you are like trying to quantify the behavior of a customer, and it's part of what is called behavioral analytics. Another approach to analytics is called data interpretation, and that is trying to interpret data to just to be able to understand the patterns and the relationship between the elements of that particular data set. Those are some of the common approaches to big data. Please feel free to ask me any question. Feel free to ask me any question before I move to project so that they can hear you.
Okay, you mentioned the predictive.
Yes.
I think in big data we don't look at descriptive and prescriptive.
I mentioned them. They are.
But it's not part of
It's not the yes. I went outside what is in the textbook. I went outside what is in, I went outside what is in this particular what is on my slide. I went outside what is in my slide. But as we advance in the training, you will see there are going to be points where we start building predictive model, and there's a point where we start building prescriptive model. So I just went, to maybe chapter 14, although we are still in chapter 1. Okay, so any other question? Today you came in late. Any question from you?
No question for now.
Okay, I thought you were going to come in today.
I know I couldn't make it,
Okay.
so I'll be here next Saturday.
Okay, so if you see the screen, you can see there is someone that he's driving towards the office. That is Osazua driving towards the office from VI. He's suddenly coming from VI, and he's kind of stuck in traffic. There is this Lagos marathon that is going taking place. Yeah. So let's just proceed. So, um, as I said yesterday, and as I've also said today, there is no limit. So, if you just pick any industry, based on my experience today, if you just pick any industry, I will probably tell you a classical application of big data in that industry, whether it's medicine or in transportation business or in oil and gas business or in travel business. It would take there's almost no industry where big data is not applicable. So with the engagement I have with some guys that work in Shell last year, so those guys said that between the point that they pick a particular location, for instance, that they want to start exploring whether oil is in a particular location to when they start exploiting oil from that location, it takes about 10 years. It takes about 10 years. Once they mark a particular location and they want to start searching for oil in that location and they want to determine whether oil is available in that location in commercial quantity, and then they will now do a structural test to know whether that location can take an oil rig, because if the location cannot take an oil rig, if you start extracting oil from that location, if the location is not strong enough, the oil rig can cave in, and that can cause what they call a blowout. So it requires a lot of capital investment, it requires a lot of money, it requires a lot of testing, and it requires a lot of time. But with the application of big data, they've been able to shorten that time significantly, and they've been able to shorten the time significantly. They've also been able to minimize the cost that they incur before they can determine whether a location is viable for commercial oil exploration. So in oil and gas, it's applicable. In transportation business, there's what they call taxi out time. So the airline companies, they have a challenge, and it's the fact that they consume a lot of fuel. They consume a lot of fuel when they are on the ground, between the time that passengers are boarding the aircraft and when the aircraft eventually takes off. They consume a lot of, they consume a lot of fuel, which, why am I disconnected? Okay. Okay. So I was disconnected, but I think I'm back now. So I was talking about the application of big data in transportation business, how the airline consume a lot of fuel in trying to within the taxi out time. So one of those problems they try to solve, you can Google it, is the taxi out problem in aviation business. It's a research topic that even the guys in Yale and Harvard, they're interested in how they can minimize the taxi out time for airlines so that they can save some of those petrol dollars that they are spending in trying to keep the airline on ground. Also in education business, in travel business, big data is applicable in government. In government is definitely very relevant in government. In fact, from my research, personal research, I've seen that the government is the biggest collector of data. Government is in charge of education, government is in charge of health, government is in charge of even transportation, some of those policies and stuff like that. So there is so much data that is collected by the government. All of these can be triangulated in a way that can help the government to become a lot more efficient in the way that it's engaging its population. Okay. So careers in big data. Indirectly, I think I've mentioned this. In Nigeria today, who are the biggest employers of people that have big data competencies? So today, based on the turnover rates in Octave Analytics, I think it's more of the guys in financial service sector. Yeah, it's more of the guys in financial service sector. And even based on the type of clients that we are getting. So the financial service sector guys are the guys that are investing a lot more in big data, just because of the fact that the kind of operations that they generate and the kind of data that they collect will require some level of analysis, some level of analysis, and they will need people that have those competencies to be able to help them to analyze those data. So based on the kind of turnover that we have seen in Octave Analytics and how people move around, we've seen that the guys in the fintech space are the guys that actually attract most of the big data talents that you have in the market today. But that does not mean that it's also not happening in the telco. But because telco, they are just 4 telecom companies in Nigeria. So because of that, the movement around is not as much as how people move from bank to bank. Early this year, we started a project in March this year, and 4 people that were part of the requirement gathering of that project on the client side, they left. Some of them left a bank to First Bank. Some of them left that bank to other banks. Then we were also working with a fintech company, eTransact. About 5 people on the project left eTransact. Some of them went to other banks. So it's the guys in the bank that actually pull in most of these big data experts. So if any of my colleagues in Octave Analytics come today and say, blessing, no, we are leaving, we are going to Paystack, or we are going to Flutterwave, I really don't get surprised, because these are the people that are actually attracting most of the talent, big data talent in the market today. So those are some of the things that we have seen. The guys in the financial service sector, whether it's the traditional bank or the fintech guys, the telecom guys are also putting a lot of interest in big data, although the telecom guys, because they have a lot of money at their disposal, they go for the very, very experienced people, and in some cases they even go for the foreigners. They bring foreigners, the Indian guys, they bring them into the country in order to help them to implement their big data requirements. So if you are looking out for a career switch, you want to change your career from whatever you are doing to big data, look out for the financial service providers, look out for telecom guys. Those are the guys that throw more money at big data experts. Then also, of course, for those that also want to migrate from Lagos to Canada, that is where a lot of people are moving to now. If you have a big data certification and you're applying for Canadian passports, you stand a very big chance. If you listen to the news, I think recently, the king of Dubai or the king of UAE he said that they are now going to be granting up to 10 years visa to some highly skilled experts. And in the definition of those highly skilled experts, there's a category that is for the AI expert and the big data expert. You know, in fact, that is the category that is generally they say highly skilled expert. Then at some point they were now very specific about people that have AI expertise, data science expertise, big data expertise. They narrowed it down to those group of people. So which means that the market is totally ready for you. So it's now up to you to build up your capacity beyond some of those things that we are even going to be teaching in this class. Build up your capacity and prepare for the opportunities. So of course, also companies like Google, Facebook, even though they have enough, they keep attracting more talent in some of those areas. So now, what are those different professions that you find under big data? Because some of you must have had things like data engineer, you have had things about data analyst, you've had things about data scientist. What is the difference between all of this? At times, you even had things about data developers. There is what they call big data developers. What is the difference between all of this? So just to be able to simplify it, the analyst as it sounds, those are people who analyze the data, and there's always going to be need to analyze the data, because as the data keeps proliferating, data keeps getting bigger and bigger, the companies want to understand the patterns and the relationship between all of these data sets. They want to look out for trends. They will want to look out for maybe seasonality within the data set. They want to look out for clues within the data that can help them to become smarter in the way they position themselves in the market. So a data analyst, is that resource that is needed. And that is where you have the big data analytics. That is where the big data analytics role, that is where it comes into play. Another role that you have is the big data engineer. Now, somebody needs to make that data available for the analyst to be able to analyze it. So it might need to integrate into different data sources and bring those data and arrange the data in a way that the analyst can connect to it and start analyzing it. So who is the guy who is going to be in charge of the design and the architecture of the big data platform? That is the data engineer. Some people call them data architects. You can call them data architects, you can call them the big data developer, but all of them fall under the big data engineering profession. They are in charge of the architecture, they are in charge of integration of multiple data sources, they will be in charge of commissioning the platform, the big data platform. So you want to go and install maybe Oracle database on the platform in an environment, and then maybe you want to install a Hadoop platform on a cluster. Those is the big data engineers that are responsible for that, and that will require you to take care of the architecture and then the infrastructure and the installation and the commissioning and the integration of data. Then you now have the third category. The third category are the people that you call the data scientists. So what these data scientists, what they do is, a data scientist is actually a combination of many skills put together at once. It's a combination of many skills put together. A data scientist will know a bit of the engineering. A data scientist will know a bit of the analytics part. The data scientist will know a bit of machine learning. Some people get scared when you mention words like machine learning, but it's not really a big deal. I think we'll get to that part in this class. The data scientists will need to know about machine learning has to do with predictive modeling. How do you take some data set and build a model, and based on that model, you can tell that, okay, a customer is going to behave in a particular way, or an entity is going to behave in a particular way, or the other way around. That is the job of a data scientist. So a data scientist, I think, beyond what an analyst can do and what a data engineer can do, a data scientist should be able to build predictive model. He should be able to bring a futuristic angle to his analysis of data. You know, that is one thing that actually differentiates a data scientist from a data analyst. So you should be able to build repetitive models that you can leverage to predict the future. Please feel free to stop me at any point in time if you have any question on any of these that we are discussing.
So this class now, what's which of this data fields is this class preparing us for?
Analyst. So there are. So this particular class. Today's we do two trainings. We do two trainings, two DASCA trainings in Octave Analytics. We do the data analytics training and the data engineering training. There's a third one, which is the data science training. There are very few people that enroll into that training. So most of the people that enroll for the data science training or that enroll for the DASCA data science curriculum, most of them, they do self-learning. Yeah, most of them, they go and read up by themselves, you know, so they just get the material from us and then we enroll them. Once we enroll them, then they go and write their exam by themselves. So those are the three categories that exist. But for our training, the training is on data science and data analytics and data engineering. Now, what we are currently, this particular class that we are having today, this one for today covers both the engineering and the analytics part. But at some point, I think from week 5, we will now branch out. The engineering guys will now focus on the core engineering techniques, while the analytics guys will focus on the core analytics techniques. Does that answer your question? Okay. So what are the skills that are required? You know, so what are those skills that are required? Soft skills are required, technical skills are required, you know. So for the technical skills, you need to have some programming skill. It does not necessarily need to be R. You just need to be able to understand programming. And the way I say to people is that, hello, please go on. Hello? Someone spoke. Hello? Okay. I can't hear you again, but please feel free to ask your question anytime you want to ask your question. Okay, so what I tell people about programming, some people are scared of programming, that at this age, am I going to start learning a programming skill? Programming is very simple. Programming is simple. You can master R programming language in 1 week if you dedicate time to it. If you take a week out or on leave, if you take a week out, that I want to master R programming language, you can go from beginner to intermediate in 1 single week. Now, how do you become an expert? Of course, you need to work on many projects. You need to work on at least maybe 2 or 3 projects before you can say you're an expert. But to go from basic or from ground zero to intermediate, that can be completed in 1 week. And it's simple. For programming languages, they come with a set of commands. It's just for you to know what are the commands that I need to perform a particular operation. If you want to do, so it's just like somebody that wants to study arithmetic. You need to understand board mass, brackets, of, division, multiplication, addition, and subtraction. If you understand all of those symbols and you know exactly when to apply them and how to apply them, you can say you understand basic mathematics, you know. So when you now start understanding how to apply some formulas, then you can say you are going from basic to intermediate level. So when you know how to do what we call a quadratic equation, you know, the almighty formula, when you know how to do square root, how to apply some function. But when you say all of those square roots, it's a combination of basic board mass that will lead to all those square roots, you know, square root and stuff like that. You are going from basic to intermediate level. When you now start doing things like ordinary differential equation, calculus, then you are going to advanced level. The same way with programming, any programming language, Python. So don't be scared that these guys are coding Python. Am I going to start learning this today? If you can take a week out. I remember some years ago, 2005, I wrote my project in the university. I had to use a programming language that is called WML, the wireless markup language, and wireless markup language, WML script. I hadn't programmed those languages before, but I just needed to do them because I needed to build a mobile application, and there were no solid mobile-based programming languages more than WML at those times. So that was what I had to use. I didn't sit down to learn it. I just said, okay, if I want to do quadratic equation, what function does quadratic equation with WML? I called the function and I got it done. So the same way, just master one programming language, and then you can easily adapt that knowledge and that understanding to other programming languages. And the same way in mathematics, the way you want to know the arithmetic functions, board mass, the same way in Python or in R or in SQL, what are those functions? Have a list of all of those functions, know what they do, and know when to apply them, then you are good to go. So programming skill is a must-have. It's a must-have. Whether, in fact, you are doing engineering, it's a must-have. If you are doing analysis, if you want to really do big data analysis, you must have those understanding. And of course, that is the essence of this class. We have experts in Descriptive Analytics that have practiced these things on the field and that are also part of the trainers for this particular class that we have. Then you have the understanding of how to hive, map, reduce. That is the big data platform itself. You know, it's like saying you need to understand Excel. You know, it's the same way. So you need to understand Excel, and you need to understand macros, and you need to understand how to use pivot table. It's the same way when you say you need to understand Hadoop, and you need to understand Hive, and you need to understand MapReduce. You know, those are big data. Those are the components of big data platform, and it's also part of what we are going to be teaching in this class. You need to have understanding of machine learning. And please, I must say this, machine learning always scare people. It is part of the curriculum of this class. Machine learning is simply, how do I predict? So if you have numbers, so if you own a mall, for instance, or maybe you are the one that own Sweet Sensation, and for the past 60 days, you know what you have sold on a daily basis for the past 60 days. If they say, okay, how much are you going to sell tomorrow and day after tomorrow for the next 7 days? Can you predict it? Yes, you can predict it because you know what you have been selling on a daily basis. So that technique, you know, that technique that you use to predict your sales number is machine learning technique. It can be maybe simple linear regression. It can be exponential regression. It can be polynomial regression. But that concept is the machine learning concept. It's probably what you do every day. Or, for instance, maybe you have a number of people coming into your organization. For instance, maybe you are hiring people. So they now said, okay, what is the probability that the next person that we are going to hire, whether it's a male or a female, for instance, or what is the probability that the next person that we are going to hire, or what is the chance that the next person that we are going to hire is going to come from a private university or from a public university? You've been hiring people for the past 5 years or for the past 10 years, and you can see all of the patterns that you have generated. So based on all the patterns that you have generated, you can tell that, okay, the next person I want to hire, the chance that the person is going to come from a public university is 80%. So what you are doing a classification model. It's machine learning. It's simple. So come with a very open mind that there is nothing that you cannot learn. So you understand? Come with that open mind. You need to understand the concept of predictive modeling, the concept of prescriptive modeling, part of what you are going to be teaching in this class. You need to understand some basic statistics. You know, statistics is very, very important. Mean, median, mode, because actually when you are doing all those machine learning, predictive modeling, it's just a combination of statistics. So statistics is part of what we are going to be learning in this class. And some of the trainers too, they have a first degree in statistics or first degree in mathematics. So I think you are going to you are in a very good hand. Then in terms of soft skill, it's very, very important that anybody that is taking this course will have a good communication skill. So you need to be able to communicate your findings, you know. So even after doing all this predictive modeling, the person you want to communicate it to is probably the MD of your company or maybe some set of investors. These people, they don't understand R, they don't understand Python, they don't understand SQL code. So how do you translate all of those technical jargons into something that makes sense to them? So both written and verbal communication is very, very key it's very, very important for people who are studying this particular course. You need to know how to query databases. You know, you need to find it easy to program. You should not be scared of programming. You know, regardless of your level in your organization, you should find it very easy to advise senior management. I don't think you should be scared of advising senior. You shouldn't be scared of advising senior management. Okay, Osazu finally made it to the class. Okay, nice one. You're welcome. Yeah, so you shouldn't, regardless of your level, you shouldn't find it difficult to be able to advise your senior management, you know, at any point in time. Because so the way it is for us is that the way it was for me. So before now, I was working in a company. Maybe I was a junior manager, but we still have to go and sit down with the MD and say, MD, okay, so for this product that we want to create, this is the pricing that we have to set for this product, and this is why we have to set that price. Although you are the one that will have to take the call, but we are advising you that this is the price that you should set based on the patterns that we have seen in the data set. So it's something that you are always going to be doing from time to time. We have a particular client that would call some staff in Octave Arena and say, call the name of some of the staff and say, I don't want to mention someone's name. Say blessing. I have executive management meeting. I have executive management meeting next week Friday. Please, can you do a report of everything that we have been doing in the past 6 months? You know, and simply what they are asking for data to show that this was the position of the business. This was how we apply analytics, and with the application of analytics, this was where we're able to take the business to. So, even though these are technical things that you are going to be learning, but you need to understand the business. It's extremely very, very important that you understand the business, regardless of where you find yourself as a data analyst. So if a bank employs you today, you need to understand the core banking processes. You need to understand the core banking processes as a data analyst or as a data engineer. If an insurance company hire you today as a data analyst or as a data engineer, you need to understand underwriting, insurance underwriting. You need to understand policy, how to underwrite a policy. You need to understand claims management. You need to understand it. because if you don't understand it, you may not be able to advise the business properly. So you need to understand how the business works. If it's Shell or Chevron that came to pick you as a data analyst or data engineering, as a data engineer, you need to understand how oil exploration, how it happened from end to end, seismic modeling, subsurface modeling, oil exploitation, drilling. You need to understand geophysics. You need to understand some of those things, because if you don't have those domain understanding, you will not even know how to properly apply data to be able to help those organizations. So that's why it's advisable. I really don't discourage people that have first degree in maybe medicine to study data science, or maybe accounting. Wherever you are, maybe it's nutrition, wherever you are, whichever way you are, come. Your domain knowledge is going to give you significant advantage over people who probably just went to study mathematics or study statistics that are data scientists with you in that same field, because you already have the background, you have the domain expertise. That is going to give you a whole lot of leverage. Please feel free to ask me any question. I think I did a little bit of career talk under data science now. So please feel free to ask me any question on that, So what is the future of big data? What is the future of big data? Whether COVID-19 or no COVID-19, the demand for data scientists keep growing. I keep this company with. Please help me to accept that I bring the person into the class. So we keep turning over staff in Untitled Analytics, and the fact is that you cannot hold down some people from going. So imagine in Untitled where maybe you pay a staff, say like a 200K, and the company comes and is offering that staff 650K. 650K. You can't say that you want to match it, because if you match it, it's going to disrupt your operation. So that is the kind of experience we've been having for those of us that are data science practitioners or that are into data science business. The demand for people that have those skills is like extremely very, very, very high. It's very high. I've seen people go to get times 5%. I've seen this year alone, this November alone, it's a boy, he went to get times 5 of what he was earning, more than times 5 of what he was earning. Another manager went to get more than times 2 of what he was earning in Untitled Analytics. Another lady went to, what is it called? What is that company called? Terragon, So it's just like that, But it's also very good. It also means that the opportunity is very wide. The opportunity is very wide. So you keep developing your skill and make sure you are relevant, and you can defend yourself anytime you are posed with some of those opportunities. But in Nigeria, there's a demand. There's a huge demand for the data science skills, and for big data practitioners. There's a big demand for them in the Nigerian market. Okay, so this takes us to the end of chapter 1 that we started yesterday. And just to recap all of this that we've been talking about, so we took time to talk about big data, which has to do with a large pool of data that is changing rapidly, that comes in varieties, and so we said that 3 things characterize big data: volume, variety, and velocity. Big data can help you in many ways. There are many applications of big data. It can help you to cut your costs. It can help you to understand the behavior of your customers. KYC for banks is when you have come, you've signed some document, they've collected your fingerprints, and they've collected your picture and the address of where you are living, and your utility bill to show that that's where you are living. But KYC have gone beyond those type of basic information. So even your daily lifestyle choices can be formed into KYC, because you need to know your customer for you to be able to know what product to offer the customer. Then data can be acquired internally, it can be acquired from external sources. Big data can be structured, it can be unstructured data, it can be semi-structured data. We talked about all of that. Then also, we also explained that structured data, they have a structured data, structured data has a specific pattern that is repetitive, while unstructured data, they're usually very complex. They come in form of picture, videos, or just text that are not very well organized. Semi-structure is a combination of the two. We talked about different approaches to big data, predictive analytics, behavioral analytics, data interpretation, and on top of that, I added descriptive analytics and prescriptive analytics. And then also, yeah, so I think that's, so more or less, that is the end of chapter 1 for this particular class. Please, if you have any question, feel free to ask me if you have any question. Otherwise, we'll just switch to the next chapter. So if you have any question, please feel free to ask me. Questions, please. Okay, so yes, let me see this. Let me see who is connected. Who's connected? Eric, Bashiru, Smiler, Femi. Femi, do you have any question? The last time you muted your microphone, we're hearing some noise in the background. Are you still there, Femi? Okay, so yeah, so in the absence of any question from in-house, any question, please tell me. If you have any question, ask me. No. Oh, okay, yes. Okay, yes. So let me get the practical. There's more here. Yes, so this is what the workbook looks like. Let me turn on my camera for the guys that are connected remotely to see. So see what it looks like in there. You can see the other people that are in the class. Okay, so let me stop sharing so that they can see you. Yes. Okay, so this is what the class looks like, and then so in the training kit, let me bring the other training kit. So this is what the training kit looks like. So it's a huge textbook for it's a huge textbook. You have to complete this, but already if you go through all of this, I can bet you are no longer at entry level. I can say that you have gone to that intermediate level. So what will now cap it up for you is now have some practical big data experience or practical analytics experience. That is what will take you to that expert level. So, and I recommend people to leverage whatever kind of data you can lay your hands on within your organization. That can help you to really build those competencies. So this is the textbook. This is what the textbook is like. There are 3 textbooks there are three materials in this. Now, so in this, what's it called? There's a big data analytics lab book, and that has all the lab work that you have to do, examples that you have to practice on your own. And for you to practice those examples, you need to set up a virtual learning environment on your laptop. It's about 8 gigabytes. So the way it is that when you are properly registered, you have access to the link for you to download the 8 gigabyte material. But of course, you can imagine with Nigerian internet how long it takes you to download 8 gig. So what we have done is that we have downloaded it and we can put it on people's computer. We can put it on people's computer anytime. So if you don't, no, there's no how. Your hard disk space should be up to like at least 500 gigabytes. So because your laptop, so it's not the RAM. It's not the RAM, it's the hard disk space. So you should have up to that. Although I don't think I have up to that. Let me see what my hard disk space is like. My hard disk space is mine is 17 gig, So 17 is the space I have left on mine, but this is I only use this for training or for I don't use it for hard stuff like that. So that is what it is in terms of the training kit. And also some of these slides that I'm using, by the time you are registered, you have access to this slide. You can see that I had to log in with my own account, and then I can use the slides to do the training. So even if you miss the class, you can have access to the slide. You can go through the slide before you come to class. So when you come to class, more or less, it's like you just asking me questions. It's not necessarily me having to talk through some of those things all over again. You have read them, so you can just ask questions. So we can have more time to focus on the practical aspect. Okay, so thank you very much. Let's just switch to the second chapter, which is the technologies for handling big data. So at least we can spend another 20 minutes to discuss that before we close for today. So technologies for handling big data. Yes, I'm sharing my desktop. Let me see what you can see there. Yes, so technologies for handling big data. So we've been talking about big data. We've talked about the applications of big data. So what are those technologies that we use in handling big data? So for this chapter, we're going to be looking at the concept of distributed computing, and it's actually because of technical stuff like this that we came up with the idea of having hybrid classes, because at times some of these concepts you cannot just teach them in the cloud like that, or you teach them virtually like that, and you believe that people at the other side they completely grab the concept. So no. So we are going to be talking about the concept of distributed computing in relation to big data. Then we will also introduce the concept of big Hadoop distributed computing environment. So a lot of people hear things about big data, Hadoop. What exactly is this thing? It's not a big deal. It's something that is part of your everyday life. It's just for you to have somebody that will explain it in a layman's way that will help you to understand how it all works. So I'll explain it in technical way, but also explain it in layman's way. And then you're also going to practice it by the time you set it up on your PC. And then we also talk about cloud computing. A lot of us are very conversant with doing stuff on our computer, but a lot of things are moving into the cloud. A lot of technology is moving into the cloud. You want to set up a data warehouse before, you need to go and buy a computer. We have a big computer in that room there that we bought for training, but we just realized that it's no longer necessary. In the cloud, you can do everything that you want to do up there in the cloud. So some of those, why is cloud computing, why is it best suited for big data analytics? We are going to be talking about it. And then finally, we're also going to be looking at what is called in-memory computing. So four concepts we'll be talking about in this chapter. Number one is distributed computing. Number two is Hadoop technology, and that will be in line with distributed computing. Number three is cloud computing. Number four is in-memory computing. And all of that, they facilitate big data analytics. So, let's start. Let's start. So when we talk about, so let me go from known to unknown. I'll go from known to unknown. When you want to go and buy a computer from, say, Computer Village, for instance, you want to buy a PC. There are some questions that you ask. You ask questions like, what is the disk space? We just mentioned that. Now, what is the disk space of that computer? What is the memory space of that computer? Is it 16 gig or 8 gig or 12 gig? You know, what is the processor speed of that computer? Why it matters is that it talks about the capacity of that computer. So it's just like when you buy a Toyota, so they will tell you, let's say you buy a BMW, is it 300 series or 500 series or 700 series? All of that talk about the capacity of the car. If you buy a car again, they can say, okay, is it a V6 engine or a V4 engine or a V8 engine or a V12 engine? All of that talk about the capacity, the speed at which the computer can run. So the same way in computing too. Remember, some of the challenges we have to deal with is the challenge of volume, variety, and velocity. You understand? Those are some challenges we have to deal with big data. So how can we solve that problem? So based on research that they have done, they now notice that many small computers, let me just put it that way. Okay, there are 3 computers in this room. So let's put a 4th one. Say there are 4 computers in this room. If you have a job to do, those 4 computers can do that job faster than how only one single supercomputer can do it. Yes. So that one led to the concept of distributed computing. And when they say distributed, so we are distributing the tasks that needs to be performed by only one single computer. We are distributing that task to a number of computers. There's a train station around here, so it's very easy for me to use train to explain it. So you want to move 1,000 people to Abuja now, for instance. You can ask those 1,000 people, okay, go and board the train, and the train will slowly take you to Abuja, even if it take 48 hours. You understand? But why do we have to? Yes, train can handle it because it can handle that capacity. But no, we don't want to use train to do it because it will take too long. We cannot afford those people to get to Abuja, after 48 hours. The other alternative we have is that we have up to 200 cars that can hit the road. You understand? And even if train is taking those 1,000 people, the train breaks down in Kenya somewhere, for instance, it means all of those 1,000 people will be stranded until the train is fixed and they continue their journey. So why not get smaller cars, maybe up to 200 cars, and we spread all those 1,000 people into 5 people per car. So even if a car breaks down on the road, at least you see the job will still be partially done. So you understand, or could be significantly done. That is the idea of distributed computing. Can we distribute the task to commodity computers, so you understand, or commodity servers in such a way that the job can be done? If it will take a train maybe 24 hours to get to Abuja, if you put those 1,000 people on 200 cars, I can tell you in 10 to 12 hours, they will get to Abuja. They will get to Abuja regardless of whatever. They'll still try and get to Abuja. And even if they don't get to Abuja, maybe it's 1 or 2 of those cars that will break down on the road. And if 1 or 2 of those cars break down on the road, you can tell the car that is coming behind, okay, let me ask one person to join this car, one person to join this car, one person to join this car. That is the exact concept of distributed computing, and that is what they have implemented into the Hadoop architecture. Now, that solution can be implemented in form of a hardware. It can also be implemented in form of a software. Sure, you understand? The hardware implementation is very simple. The hardware implementation is that just bring commodity computers, bring them around, make them available. Then the software will now be the resource that will manage all of that coordination. So if a car breaks down on the road, you can say, okay, people in this car, okay, leave this car, you go and join this car, you go and join this car, you go and join this car. And then you update your database. You say, okay, this particular person that was coming on car 51, because car 51 broke down the road, we have moved him into car 62 and move this on to car 75, and then to update that database, and people keep going to their destination. That is the whole idea of Hadoop technology itself. So I think I have broken it down. So that is the best explanation people ever like, and it's because people are in the class with me. That's why I feel that is the best explanation. The other times people are just there out there remotely, so at times it's difficult to like make them to see their reaction when you're explaining, and because you cannot see that reaction, you cannot be sure whether they are getting the concept. So so distributed computing, it's a method in which multiple computing resources are connected within a network. So rather than only one supercomputer getting the job done, multiple computing resources, and when we say computing resources, hard disk space, processor speed, and hard disk, processor speed, and memory, they are connected, they are connected in a way that the task that needs to be done is distributed around them. It's a lot faster, it's a lot more efficient. Of course, I gave the train example. The train can break, and the train breaks down, you cannot continue. But if you distribute it among those cars can be going. If anyone breaks down, you can redistribute the work. So the work can be distributed among those computing that is in a faster and a more efficient way. And even if it's a complex task, the processing power of a standalone personal computer can also be enhanced. So, which means that if these computers are the ones that are getting the job done, so if you even think that the computer is slow, you can go and add more memory to it. You can, if you think the disk space is not enough, you can go and add more disk space to it. You understand? But if it's a train, they have broken train down into coaches. You can go and add more coaches to it. You understand? But if you add more coaches to it, it also means that what the engine has to store, it tries to drag more. That means you are slowing down the effort. But if you add more memory to this, that means you can a lot faster. You understand? So when you now have a job, so the job in this case is 1,000 people, you want to move them to Abuja, you now break the job into smaller chunks. So the same way, when you have a big data job that you need to do, instead of getting only one computer to get the job done, you can now break it down into smaller units and distribute it among all the computers that are interconnected. Now, that is, when you buy a computer, I say it's a dual core processor. There is also quad-core processor. What it means is that computer has 2 processors in it. If it's quad-core processor, it means that the computer has 4 processors in it. That is the idea. It's the concept of distributed computing that they have built into this. Like, okay, this computer has about 4 processors, and if you have a job that has to be done, it will be distributed among all of those pieces. The greater the processing power, the faster the computing. So the more processing power that you have, the faster the computing, and that will be more suitable for big data jobs that needs to be done. Remember, why this is important is that there are 3 problems we need to solve: the volume problem, the speed problem, velocity problem, and the variety problem. Those are problems we need to solve. Yeah. So there is this diagram. So this diagram is just showing distributed computing. So here you have independent computers. You have independent computers that are connected together in a way so that when a job is submitted, the computers within the distributed system can get the job done. And so what I've explained is display computing. The other one is what is called parallel computing. So parallel computing, the concept about parallel computing is just simple, and that is when you have multiple processors that are connected to one memory. So how can I explain that? Multiple processors connected to just one single memory. So if you look at this diagram, so all of these are independent computers that are connected within a particular network. So if you decide to remove one of these, if you disconnect one of these computers, the distributed network still exists. That is not going to shut down the network. It only means that okay, one of these computers is no longer available. But in distributed computing, in display computing, in parallel computing rather, for parallel computing, you have multiple processors that are connected to a memory. So for parallel processing, you only have more processing power, but it's still one single computer. In parallel processing, it's still one single computer. So a parallel system has multiple processing units attached to the memory. You have multiple processing attached to the memory. All the processing units share common memory and they have direct access to the memory. So I'm looking for another example to explain parallel processing, but it's just as simple as that. Multiple processors, they're accessing one single memory, while the other one is they are independent processors with their own memory that are connected together in a way. So if a parallel system shuts down, it is completely shut down. So you understand? If it shut down, it is completely shut down. While the distributed system, if one of the computers in the distributed system is shut down, is still available for processing. Yeah. So so those concepts, they are needed in managing big data. It's needed in managing complex data. And when you now need to analyze big data within a distributed system, what happens is that the job is broken down into smaller tasks, and then you now survey what are the computing resources that are available to handle all of those tasks. Then you now assign the job to the different interconnected series system. It's very intuitive. It's very simple. Of course, before now, it's only one guy that will do the job. Now we now have multiple people that can do the job. We now break down the job. We assign, okay, who is available? Who are those people available? Or what are the resources that are available? We have 10 out of 20 resources available. Assign the job to the 10 out of 20 that is available. And once it's assigned, if the job is completed, you collate the result and you combine it into a single unit. That is the concept of distributed computing. And when you go to the internet, that is also what happens on the internet. However, that does not mean that there are no challenges to it. So, and one of the biggest challenges that you have in that network is the problem of latency. So by the time you are breaking the job, and so you have 1,000 people, you ask them to go and board the train, they will just go and enter the train, it's gone. But this time around now, you want to assign 1,000 people to 200 cars. Okay, which car do you want this person to enter? This one is coming with his wife, this one is coming with his children, this family, they are more than 6, so how are you going to distribute them? And you need to track where you are allocating people to at any particular point in time. So it comes with its own challenge, and that is the latency, which is the delay. The latency is something as delay, the time constraint between the assignment of tasks. So latency is the aggregate delay in the system due to individual tasks that involves large amount of data. And regular big data systems, they suffer that latency problem. They suffer that latency problem. So how the problem is solved is a combination of parallel computing and serial computing. If you combine the two concepts together. So let's go back to this diagram. So if you decide to put, if you decide to connect, so if you decide to connect a parallel system into a distributed network, you may be able to solve the problem of latency. So imagine, so here you have one processor and one memory. So you imagine you have 3 processors and 1 memory under this distributed system. 3 processors and 1 memory, 3 processors and 1 memory here. At the end of the day, you would probably be able to reduce that delay that you normally encounter when you have to manage big data. I think it's a lot of information for today. I'll give you some time to process all of this. We've had some yesterday, we've had some today. I'm going to pause a bit so that I can process it. Then we continue on this note. Next week. But I'm going to be available to take your questions. And if you have questions, then I'm able to take your questions. There's another class that is starting by 2 o'clock, and my colleague there is going to start that class. I should have connected that computer to this. Do you understand? So please, I'll borrow that PC and give it to him so that he can take his class. But I'm going to be available. So please, for guys that are connected remotely, I'm still available in case you have any questions. I'll take your questions. Okay, so I think by next week will be a lot more than this. Yeah. So okay.
To solve the problem of the latency, basically this will require computers in the distributed format.
Yes. Answer yes. Yes. So in computing generally, for those that study, for us that study computer science, I read computer science, there are 3 things that we try to manage. Number 1 is speed. We try to solve the problem of speed at every point in time. We try to solve the problem of space. Speed, space, but that space, there are 2 types of spaces. One is the memory space. The other one is the hard disk space. One is the memory space. That is it. So when you're working with Microsoft Word, for instance, your file is saved. Your file is saved on the disk. But whenever you want to start working on it, you now double click it. You now open that file. By the time you double click it, what you are doing is that you are issuing a command that you copy that file from the disk and put it in memory so that you can work on it. After you work on it on memory, you save it. If you don't save it and your PC gets shut down, it is what is on the disk the last time that will still be there. The last time that you save it, that is what is going to be there. So 3 things we try to manage. We try to manage memory, we try to manage disk, and we also try to manage the processor speed. So that is why when you go to buy a computer, you are asking what is the RAM size of the computer? What is the processor speed of that computer? Is it 1.7 gigahertz or 2.4 gigahertz? And the third one is what is the disk size? Is it 1 terabyte or 2 terabyte? So those are 3 problems we try to solve at any particular point in time. So when the data becomes bigger, it means that the need of solving those 3 problems become bigger again. And how do you solve it? More processor. If you give me more processor, I'll be able to solve the problem faster. If you give me more memory, I'll have more space to be able to do my execution. At times, there are some Excel files, you want to open it. You just see that once you double click it, you have to wait for a while before the Excel file is loaded. Because the file is very big. Sure, you understand? But if you have a very big space, if you have a very big RAM, it will just load it in the twinkle of an eye. You just load it fast. So if with distributed computing, big data is still having the latency challenge. How we can solve it is to introduce more processor and introduce more memory into it. So which means in distributed system, you have one processor, one memory. In parallel system, you have multiple processors and one memory. So can we take parallel system and connect them in the distributed network and see how it's going to perform? Simple. That is one way to reduce the latency problem for big data. The guys on the other side. Tunde, any question? Tunde Bashiru, if you have any question, please feel free to ask.
No question. Interesting.
Okay.
Yeah.
Okay, thanks a lot. If there is no question. So, Eric, Bashir, hope to see you, and Smiler, hope to see you guys next week. This is the end of the class. But feel free, you can walk in anytime during the week. We are always there, or at least there's always going to be somebody. There's always going to be someone here that can answer your question. It does not have to be me. Just walk into Descriptive Analytics, let them know that you are one of the current DASCA cohort, and ask your question. At least there's always at least a day someone who has taken the DASCA exam or that is working on a related project that comes to this place every day. So you can feel free to ask your question.
So we can bring our laptops for the lab stuff.
Anything.
Thank you.
All right, take care, bye.
Hello, can I ask a question?